This is Steve Piloff from George Mason University. We're going to talk a little bit about rates and compounding. Start out with some terms. Compounding frequency captures how often interest or returns are computed. So basically, is it compounded quarterly, monthly, annually, semi-annually? How often is interest on interest and principal or returns on what was there before computed? How often does compounding take place? The compounding period is the period determined by the frequency. So if interest is compounded quarterly, then the compounding period is a quarter. If it's compounded annually, then the compounding period is a year. And then we have the period rate or the periodic rate, which is the rate that corresponds to one period. So if interest is compounded semi-annually, the compounding period would be a half year, and the rate for a period would be the rate for a half year, the half year rate. A lot of times, interest rates and returns are presented in terms of an annual stated rate and then the frequency of compounding. And what that means is that the rate that's given is for a year, and then you're told how often compounding takes place. So 10% compounded annually is 10% per year compounded annually. So once a year, interest returns are accrued and the full 10% goes in. 12% compounded monthly, even though it's compounded monthly, it's not 12% per month, it's 12% per year compounded monthly. And since it's 12% for a whole year, when interest and returns are compounded for a month period, a month is part of a year, there's a whole bunch of months in a year, you'd need to figure out what the rate is for a month that corresponds to 12% per year. And that's pretty straightforward and something we'll talk about later. 8% compounded quarterly, again, is 8% per year, compounded quarterly, so every 3 months. So you have to figure out if it's 8% for the whole year, what's the rate for 3 months? And finally, 16.3% compounded semi-annually is the same as 16.3% per year, compounded semi-annually. And it's important because you could have two loans, two assets, two investments, and they have the same stated rate. They're both at, let's say, 16.3% per year. But if they have different compounding periods, then that has implications for which loan would be more attractive or which investment is expected to increase wealth the most. And so understanding the effect of compounding periods in order to make good decisions is important, and that's something that we're going to be looking at. I want to go through an example to highlight how compounding works and how you can have two rates that are the same, two stated rates that are the same, but because of compounding, it has a real effect as far as what's, in this case, a loan, what's owed. So we have a loan with a stated annual rate, interest rate of 8%, compounded annually. Then what that means is every year, 8% interest is accrued on the loan. So the bank gets together and would say, okay, what did they owe a year ago? 8% of that is how much more they owe now. So suppose on January 1st, we borrow $100. At the end of the year, we have to pay back all principal, which is $100, and all interest. Because interest is compounded annually, December 31st is the day that interest is figured out. It's 8%, so you'd owe $108. The original 100 captured by the 1 plus the 8% of the 100. That's why we multiply by 1.08. We owe $108. Now, we have a stated annual interest rate of 8%, but now it's compounded quarterly. And I'm telling you this now, later we'll learn why. That means every quarter interest of 2% is accrued on the loan. So we know it's 8% for the whole year, and we need a rate, every 3 months, 3, 6, 9, and 12. The bank will get together and say, okay, how much is owed on the loan now, which would be 2% of what was owed the previous quarter. And so 2% per quarter for 4 quarters corresponds to 8% per year, which is something we'll talk about later, but I'm asserting it now. So again, we borrow $100 on January 1st. At the end of the year, in 1 year, all principal and interest will be repaid. So we start out with 100. 3 months later, it's interest time. 2% of 100 is $2. We now owe $102. 3 months later, it's time to add an extra 2% to our loan, which is now, as far as what we owe, not 100 but 102 because of the accrued interest. So we now owe 102 times 1.02, which is the same as 100 times 1.02 squared, $104.04. That 4 cents is interest on interest. 3 months later, September 30th, we owed 104.04 back on June 30th. Now we're going to owe 2% more plus the amount we started with. We're at $106.12.1. And notice it's 100 times 1.02 times 1.02 times 1.02, and we just kind of, 102 is 100 times 1.02, 104 is 100 times 1.02 times 1.02, and so it can express it that way. End of the year, we say, 3 months ago we owed $106.12.1. Now we owe 2% more plus the 106.12. We now owe $108.24.3. So notice that now when we have quarterly compounding, because of the interest on the interest, we actually owe 24.3 cents more than when it was just annual compounding. And that is because of interest on interest, which we experience with quarterly compounding and not annual compounding. So we had two loans, same stated rate, but interest on interest because of compounding made a difference.